Okay, so we are going to take the numbers that are in the y column here for the exponential graph and put them in the x column for the logarithmic graph. So same numbers, just change columns. Right, and then we're going to make the columns that are in the x be our y's. That's what happens on inverses. The x and the y's switch. Right, and these are the numbers we're going to graph for log base 2 of x. So this time 1/8 is the x, so just barely over a teeny tiny bit and then down 3. And then over a little bit more and down 2. Over a half and down 1. All right, and then we have some normal points. Right, and then that is the graph of a logarithmic graph. And a logarithmic graph is going to have a vertical asymptote. So it's going to be a vertical line that it kind of goes flat beside. And so on the parent function, the one that didn't have any shifting, the vertical asymptote is going to be at x equals 0. Right, and I'm trying to think. Most of the functions we've used this year, the domain is all real numbers. This one is not. So the domain is going to be x is greater than whatever this vertical asymptote is. So as soon as you have the vertical asymptote, you also have the domain. Just change the equal sign to greater than.
Why is that asymptote 0?
Because this is where it goes straight. Whenever x is 0 is where it goes straight. It doesn't ever go past that. And what do you guys think about the range? There's an arrow going down and an arrow going up. So the range is all real numbers. So the range on all of the logarithmic graphs is all real numbers. Okay. So one thing I want you to be able to do pretty easily today is just look at the equation and tell the vertical asymptote. And so the shift in the parentheses is going to give you the vertical asymptote. So if you add on the inside, which direction is that going to shift, left or right? Do you remember? All right, so adding inside is going to shift to the left, and that's going to give you a negative number. And then subtracting is going to shift to the right, which is going to give you a positive number. So whatever you have inside those parentheses, you just use the opposite sign for you to give the asymptote. All right, so let's do that on number 1. On number 1, we're going to start off with this function, and we're going to give the vertical asymptote. We're going to look inside the parentheses. Since this is a plus 3, your asymptote is going to be x equals negative 3. So use the opposite. And then as soon as you have the asymptote, you're going to go ahead and say the domain is x is greater than -3. So just change the equal sign to a greater sign. And all of these are going to have a range of all real numbers. Okay, so all that you can get just by looking at the problem. Now to get the x-intercept, we're going to have to look at the graph. Okay. So we're going to go to y equals in the calculator. And then we're going to type this in. Do you guys remember how to get the log-based stuff? Good. So alpha, window, 5. All right, and then I'll just go ahead and put my base of 2, and inside the parentheses, put x plus 3. All right, so let's talk about the x-intercept for a second. The x-intercept is going to be whenever y is 0. So we're going to go to the table to find. All right, and then if you forget how to get to the table, it's second and then graph. Okay, so I'm going to do second, graph, and then I'm going to scroll. Whoops, I'm going the wrong way. I'm going to scroll until I see where the y is 0. Oh, there it is. So the y is 0 when x is 2. Oh, sorry, x is -2. So that's going to make our x-intercept be the point -2, 0. So I'm also going to go ahead and graph that. All right, and then I'm going to get a few other points just from our table while we have it up there. So looking at the table, I can also see I have a point at -1, 1. Now I'm not going to graph these decimal numbers, but I'm going to graph 1, 2. And we'll do 5, 3.
He can serve one where you say like
Say it again. What?
you do like certain points.
I'm scrolling on the table and I'm finding the points that aren't decimals. So I did 5, 3, 1, 2, -1, 1, and -2, 0. Now all these here that have errors is because they're not in the domain. So there won't be anything graphed there. Okay, now I know that -3 is my asymptote. So the graph is going to get close to that, but not quite get there. So I'm just going to come like straight up at -3 and then curve through those points. And that's my logarithmic graph. Right, so it can be a little time consuming. We're really focusing a lot more today on this and less on the graph. We're only going to do a few graphs. All right, so let's look at another one. So the asymptote comes from what's inside the parentheses. What if there aren't any parentheses? Well, if there's no parentheses, then that means there's no adding or subtracting in the parentheses. So it automatically means that your asymptote is 0. All right, and then that means that the domain is that x is greater than 0. And all of these ranges are going to be all real numbers. And then we're going to have to look at the graph or look at the calculator to find the x-intercept. All right, so I'm doing alpha window 5. Now the calculator will always give you parentheses. So in this case, x is the only thing that goes inside, and then that -1 is outside. All right, and then I'll go to the table and start scrolling around. All right, so all these are in the domain. There it is. So as soon as I see 0 for the y, I know that my x-intercept is at 3. All right, so I'll always go ahead and graph my x-intercept and then just kind of scroll around looking for numbers, other numbers that I can graph that aren't decimals. Now, if you like graphing decimals, you can graph decimals if you want to, but there we go. I'm going to do 9, 1. All right. Now I know my asymptote is 0, so I'm going to be close, but just kind of going straight up and then curve through those points. And there's my graph. All right, and then the rest of these examples are just doing this part right here. All right, so hopefully we can just look at number 3, look inside the parentheses, and just do the opposite of that number for our asymptote. So just x equals +1, which makes our domain x is greater than 1, and our range automatically is all real numbers. Now we do have to use the calculator to find the x-intercept. So let's just type it in real fast. Scroll around a little bit. There it is. So the 0.20 should be my x-intercept. All right, now we look at number 4. So what's the asymptote when there's no parentheses? 0, good. So x equals 0, x is greater than 0, all real numbers. Then so in this case, x is the only thing in the parentheses. All right. There it is. 90 is our x-intercept. All right, so you guys try 5 and 6 on your own. If there's something that you're not quite sure of, let me know when I'm walking around.
How do you do fractional calculator?
You can either do, I would probably just do 1 divided by 2, or there's another way to do it, but that's the easiest way. So those three things on each of those you should be able to do in like 5 seconds, like really. But x-intercepts are going to take some time, but those three don't take hardly any. All right, so what'd y'all get for your x-intercept on 5, 7, and 6? It's also 7. What questions do you all have on these graphs? All right, let me give you all your worksheets.